Okay, so our next little segment here is going to be over residuals. Again, if we had a definition for residuals, which is what we do right off the get-go here, it is going to be the vertical deviation between the observation and the least squares regression line. And if I had to sum all the residuals, the sum is going to be 0. So let's go look at this line. So what we have is we have a prediction line. That line is going to be the predicted value. The data point then is going to be considered the observed value. So what we're figuring out is we are finding this vertical deviation from what we observed versus what we predicted is what we're trying to do here. So, excuse me, if we had to come back to an equation here, it is going to be observed minus predicted. Let's back up a step. Back up a step. There we go. Observed y minus predicted y. Or in other words, if we had to write this out in equation form, the observed y would be just y. The predicted y, remember a prediction is given by the hat. So y minus y hat is going to be the predicted value. Okay? So this is this residual here for, this is what, 105? I'm not for sure. It appears that the residual, this residuals plot doesn't match up with our body weight versus backpack weight, but that's what we had. So this residual here, okay, we observed 24, but we predicted something like 25 and a half. Okay, so we take observed minus predicted. That's going to be a negative 1.5, which means a negative residual means we over predicted. Okay, my predicted value was more than my observed value. Okay, so if we go on through here and figure out and here's a better example of the residuals plot. We're going to make another scatter plot. We're going to make a scatter plot of all my x values plotted against the residual value. Okay, the purpose of doing that is to tell me if it is linear or not, because sometimes it will be curved. If, again, I can look at a residuals plot and see no pattern, then I know that the association is linear. Okay, so that's what I'm trying to do. So if we look down here, again, we were plotting, looks like non-exercise activity versus the fat gain. It was one that I took out. But anyway, we see the residual for that point is going to be this distance right here. So that was for what, negative 100. So we can come over here and see at negative 100, I have that residual there. So we're just plotting those same exact points, okay? If I have my last point out here is, looks like about 701. If I come over right here, 700, and it barely had any residuals. So, or again, the residual is the difference between the observed value and the predicted value. So the residual for that point is that distance there. The residual for this point is going to be that distance there. So I have positive residuals and I have negative residuals. And again, if I add up all those residuals, then that difference is going to, that sum is going to be 0. Okay, this is going to cause a negative residual right here, which means it's an over prediction. My line over predicted my thing. Is that in my notes somewhere? Do I want to write that down? We won't. I will write this down because I believe this is a part of when we have to describe the residual for a given point. We have to talk about over-predicted and under-predicted. So a negative residual means that my predicted value was larger and we're going to have a word for that. We call that an over-prediction. If I have a positive residual, that means the observed value is larger. and that means it's an under prediction. But I went a little bit off course here. That's not necessarily what we were talking about in this section right here. It all ties into the residuals, but here we're trying to determine if I look at a residuals plot, if that residuals plot indicates that I have a linear relationship or a nonlinear relationship. So when we talk about this guy here, okay, there is no pattern. This lack of pattern would indicate this is a linear relationship. Okay, here, this has a distinct pattern. I can see we do this very, very parabola-like. So this pattern would indicate that it is not linear. And again, over here, we have a pattern which is going to indicate not linear. All right, so we got one big old long hairy problem to roll ourselves through here. I don't know, this may take quite a while, but we'll get through it. Okay, given in the table is the calories versus fat content of 20 familiar candy bars. We're going to answer the following questions about the association between fat and calories. So once we determine a least squares regression line, again, the AP exam is not about data entry. It's not likely to do this. It is likely to give you a computer output or the summary statistics. Again, if we were to scroll over here and look in my in my stats, I believe I've already entered this. So let's look here. L3 and L4 is where I've placed this at. So that means that we're going to go back into stats. We're going to go over to calculate. Again, we choose a linear regression, which in this case is option 7. I believe yours is going to be option 8 when you get there. So I'm going to clear this out because my X value is stored in list 3. This is going to be a little bit funny for me. You have an L4, an L5, and an L6 above your 4, 5, and 6 key. I do not. So I have to go, if you look above your stats button, there's a list button. We can also get to my a list from there. So that's where I'm going to have to get list 4 at. I haven't, we don't necessarily need to store this. I'm going to go ahead and store this, and we'll go back to my scatter plot and re-look at this. So we're going to store this again in variables, functions, and Y1. So that's going to store that in Y1, and we're going to go ahead and calculate this. Okay, so those are the key things that I have to remember. I have everything written down in my notes key, so that's not a big deal that I write these things down. But this gave me everything I need, and you can't see me point to it. But we have a y-intercept A, we have a slope B, and we haven't got to r squared yet. And then we have an r value of 0.497, which is going to be a middle-of-the-road strength. Okay, it's not going to give us anything that's very weak or very strong. Okay, but that is creating our linear regression line as far as the mechanics of it. You know, so the other thing I want to do here again was also want to look at the scatter plot of this. So we're going to go into plot 1, which is where I have my scatter plot at. It's still on a scatter plot. However, I'm going to clear this out for L3, and I'm going to clear this out for L4. Okay, and we'll go ahead and zoom, and not 9, zoom 5. You'll zoom 9. And again, that's where we have, you know, this is the picture of what we have here. Okay, I wonder what this button does. Choose what format you want to share. And I don't know. Let's click on back right on it. If I change it into a PDF, let's see what happens. I don't know. Let's try markup. Okay, I actually have no idea what I'm doing. This is maybe a pain. But anyway, we can see, maybe I can come back to it. Let's try that. Okay, I'm gonna leave this alone for now. We're gonna stay here. I'm sorry, I'm learning things on the fly as I'm giving this lecture. I shouldn't do that. But anyway, again, we're gonna come down to our variable over here. Okay, our two variables are fat and calories, and before I ran my linear regression, I should have figured out which one is which. I didn't do a very good job of modeling that. However, we're going to use our fat to explain how many calories are in my particular candy bar. Okay, so that means when I go to make that equation, I'm tired of orange, let's go red. We made this my X list, and this was my Y list. Okay, and again, my explanatory variable and my response variable. So we're going to have a calories hat. Again, the hat there is for the prediction. And if you don't have a hat on your variable, it's going to be wrong. 161 plus 6.5 times my fat. And that's the part we had to remember. And again, it's hard to do on this. If I go back to, okay, then close. Why are you doing that to me? Where'd my calculator go? Anyway, let's just, I'm wasting time now. We have determined the least squares regression line. All right, find the correlation coefficient R, okay? If we went back to my computer output, which is what I was trying to do, that was 0.4978. And what it's never gonna just say find, it's always gonna be find and interpret. So we're gonna add that in there, okay? And so again, interpretation is going to be context, I'm not sure you can read that. Strength and direction. All right, so here we go. The relationship between fat and calories is, so that took care of the context. Moderately strong and linear. And actually, I goofed that up. Moderately strong, moderately linear. Ah, man, I apologize. Let's try again. Moderately linear and positive. I need a direction there. Whew, wow. See if I can screw that up anymore. My apologies. All right. Again, this is practicing stuff we have already practiced before, but again, it's always good to do that because these are going to be sentences that we need to try to ingrain within our brain. Okay? So the slope, that slope was, if I go up to my equation, that slope was 6.5. And so now we have to interpret that in context. Okay? So that means for every additional gram of fat, the predicted calories will increase by 6.5 calories, and we're going to put on average. We could have about, or we can put on average. We just have to make that into a fuzzy number, because if we don't include that, that's indicating that every single time it's going to go up 6.5, which isn't the case. Our predicted value will, which is what we have. Okay, sorry, I got cross-brained there. The y-intercept, we'll pick a different color for that. Okay, my y-intercept is there. So that is going to be 161 for a candy bar with 0 grams of fat. A, it will be tasty. B, the predicted calories will be 161. Okay. All right. So moving on. I just realized that this seemed weird because I had it in a vertical mode versus sideways. So maybe that's why. Maybe I'll be easier to write now with it blown up a little bit. All right. The predicted calories for a candy bar with 9 grams of fat. So here we go. We got our calories hat is equal to 161 plus 6.5 times 9, which is going to be 219.5 calories. So going back to a question like this 3 years ago on the AP exam, where you could easily drop 9 into an equation. Again, all of this is necessary, okay? Context, work, and actually and answer, all right? Those are the 3 things that had to be there. So always get in the habit of showing your work, okay? Find and interpret the residual for a Reese's peanut butter cup. Okay, if I look at my chart, the Reese's peanut butter cup had 15 grams of fat in it. Okay, so my residual is going to be the observed. What did we observe it? If we go up to my chart, we look for the Reese's peanut butter. Here's my point that I'm talking about. So I have 15 and 260. So we observed 260 calories. We predicted 161 plus 6.5 times 15, and that equals 258.5. So if I talk about finding my residual is going to be the observed value minus the predicted value. So observed was 260 minus 258.5. So we end up with a residual of 1.5 calories. Okay, that was the find part. Now we also need to come over here and do the predicted part, interpret part. Okay. The least squares. Actually, I hate writing out least squares regression line. It's silly. So here's a least squares regression line. That is acceptable. Now, because my observed value minus my predicted value is positive, my least squares regression line underpredicted. The real content by 1.5 calories. Okay. It says make a residuals plot, and what does this plot tell you about the linearity of the data? And again, in making this residuals plot, you know. So actually, let's talk about that residuals plot for a second before we just. It's one of those things where we're not going to have to make it. All we're going to have to ever do is interpret it. But I wanted you guys to see how it is made. So I've got to get my calculator back open. So what we need here is we need to find out what all of these residuals are. That residual, this distance, this distance. So there's a lot of different distances we have to find here. Okay. So that residuals plot is found. I guess I can delete that PDF. Okay. Well, that was a learning experience. If I go into my list again, so I hit Shift and Stats, we see option 7 is residual. So I am going to show you how that we would make a residuals plot with my calculator, but just know that all we have to be able to ever do is interpret a residuals plot. Okay, so I'm going to go back into my stat plot, and I'm going to go into number 1, and I'm going to plot the fat content, which was L3, but I'm going to plot it versus not L4, which was the calorie value. I'm going to plot it versus the residual, and that's going to be in 7. So what has to happen, though, is you have to calculate your linear regression first, so that way it can make a residuals plot. As soon as you do your linear regression, it is going to make your residuals list for you. Okay? So we're going to go ahead and look at that plot. So that means we have to zoom and zoom 5. So again, I am not after the world's best picture of this. We're just going to sketch this as long, I am not looking for exact points at all. Okay? So if I go back out to Notability here, here is 5, here is 10, here is 15, and again, if we were going, it'd be much easier if I could see my plot to look at it, but it's going to be something that looks like this. And again, I'm not after the Mona Lisa here. We just have to see that there's no pattern, which is going to indicate that the linear is appropriate. Okay, all right, last thing, and then we're going to get this problem finished, wrapped up, put to bed, and then I can stop talking to you. So we're going to describe this again. We're going to use SOFA for it. Okay, we always want to include context. So we're going to say the relationship between fat content and calories of candy bars is, and again, this is, you can keep writing the sentence if you want. We can write SOFA out to the side, and then you can fill that in. It's fairly indifferent as far as what to do. Strength was moderate. Again, with that R value. There appears to be no outliers. Again, we don't have any defined way of doing this. The form is roughly linear. And the direction is positive. Alrighty, and that's going to wrap it up. I am going to be done with this video. I think this one turned into a little longer than usual, but